Thanks very much for joining us for episode 35 of InTek, Freight and Logistics, the podcast. I'm Kevin Baxter, and on this episode, we're discussing machine learning and how it can enhance supply chain management with the co-author of a recent paper on this very topic in the Harvard Business Review. Let's get started. Dr. Naren Agrawal is the Benjamin and May Swig Professor of Supply Chain Management and Analytics at Santa Clara University's Levy School of Business. In addition to teaching, Dr. Agrawal has consulted with major companies, advised startups, and published numerous literature on supply chain management, including that aforementioned piece that we are about to discuss. Dr. Agrawal, thanks very much for joining us.
Thank you, and good morning, Kevin. I'm delighted to be here. Thanks for inviting me to participate in this podcast.
Yeah, we appreciate it. And I gave a little super brief bio snippet there, but tell us a little bit more about yourself and your background in supply chain management.
Sure. So I was originally trained as a mechanical engineer during my undergraduate years. But soon thereafter, recognizing the power of information, analytical methodologies, and computing in delivering values to companies, I made the switch to operations management. So I got a master's in operations research and a PhD in operations management and supply chain management from the Wharton School. And once I graduated, I started teaching here at the Levy School of Business at Santa Clara University in the Bay Area. Right in the heart of the Silicon Valley. So over the last 3 decades, most of my teaching, research, and consulting work has primarily been in the area of operations and supply chain strategy. I teach courses in operations management, supply chain management, and the use of analytics and optimization methodologies to our master's, MBA, and executive MBA students. And have been invited to conduct executive education on these topics at several companies. In terms of research, most of my work is focused on a variety of topics related to supply chain management, inventory strategy, pricing, markdown optimization, forecasting, design and analysis of supply chain networks and contracts, and what's referred to as the after-sales service supply chain design. I've primarily worked on these topics in the context of the retail industry and the high-tech industry. So companies like telcos, semiconductor equipment manufacturing, aerospace and defense, and consumer electronics. And as you mentioned, I've published my work in some of the leading academic and practitioner-oriented journals, and have also edited a book on the topic of retail supply chain management. So that's just a brief background as far as supply chain management is concerned.
Great. So talking a little bit about the companies that you've worked with, obviously you mentioned you're close by Silicon Valley, so you got the technology piece right there. And also on the list, I saw a lot of retail companies that many are familiar with. Was there anything that you saw sort of as a commonality, a through line of those companies being successful? Was there like a philosophy or any kind of secret sauce that seemed common to you there?
Yeah, Ken, I think that's a really important question that you asked, and I think this is a question that every company, every business should always keep front, right, and center in their mind as they consider any decision. I think that, and I think the secret sauce is really not that difficult. I think that companies that we consider as our exemplars in any industry, I think are almost always the ones that keep their eye on their core mission. And that is really what should guide their strategy and the execution of that strategy. So, for example, in the retail industry, if you think of a company like Walmart, which all of us would agree is kind of the best in class, their stated mission is to save people money so that they can live better. And I think they're a wonderful example of a company where everything that they do, especially in the area of supply chain management, is guided by that core mission. It drives their decisions about assortment planning. They only want to stock products that consumers really want and need. Their sourcing strategy, their pricing strategy, they're the ones that pioneered the EDLP, or everyday low pricing strategy, which is a key source of efficiencies in their supply chains. Their decisions about store locations, store formats, their distribution network, their fulfillment centers, their fleet. All of these are really guided by that one core mission. And I think that's really the key point that you'll find underlying almost any successful company in any industry. So I'd say the key through line really is to be able to focus on your core mission.
Great. Yeah. I think people know it too. So it's one of those things like if the customer base and the public kind of knows what the company is about, that's sort of a good reinforcement of that core mission as well.
Yeah. And I think, all too often companies kind of get sidetracked and get excited about things which are kind of the flavor of the month or flavor of the year. And sometimes it just distracts them from their core mission.
So let's jump into the article. So talking about machine learning, the title of the article, make sure that I get it fully in here, how machine learning will transform supply chain management, again, in that Harvard Business Review. First off, so how did you, and you had a couple of co-authors on this piece as well, how did you arrive at the topic to write about?
Yeah. There are three co-authors on this article. Two of the three co-authors of this article and I are all professors at different business schools. And we all focus on teaching and researching issues related to supply chain management and developing innovative analytical methods to solve some of the most pressing challenges in this space. So naturally, solving some of the underlying pain points with respect to supply chain planning is very near and dear to our hearts. And our position in academia affords us the opportunity, and I guess the mandate, to stay focused on these core problems. So we've been very closely following the most recent developments in technology, especially the ones coming out of Silicon Valley. Developments in our ability to store and access large volumes of data very quickly and efficiently, developments in cloud computing infrastructure, and developments in our ability to leverage these capabilities to process information using the latest machine learning techniques. And I think finally, the developments in our ability to optimize large-scale problems very quickly using these technologies. So, on the one hand, these amazing developments are taking place right around us. But on the other hand, we found that supply chain planning in most industries and in most companies was still stuck in kind of the old world. The companies continue to blame forecast errors as the main reason for their inefficiencies. End-to-end data are available, but rarely used, and when used, not very well. Analysis, when it's done, is often pretty ad hoc and relies on very simplistic and stylized mathematical models. And so the upshot is that companies are unable to react very quickly to new information and rely on slow and legacy planning processes. So, given our collective passion for helping companies make their supply chains efficient, it seemed to us like the time was perfect to leverage the latest technological developments to solve the problems that we were focused on, and that's really how we got started on this topic 3 or 4 years ago.
So obviously, I guess if you started 3 or 4 years ago, it continued to evolve a bit as well over that time period, as we've certainly seen continued proliferation in AI and machine learning. All of that stuff is constantly changing.
Mm-hmm.
So one of the pieces where you talk about planning and effects on supply chains are things that everyone knows occur that are disruptions, common disruptions. So in recent years you had COVID, which I guess timing out with your 3 to 4 years ago thing might have been a little bit of a push there for this piece.
Yeah.
Russia, Ukraine has happened since then. Other things that you call black swan events have occurred as well. But regardless, it just shows there's always something coming up, and there's always a need to be able to plan your supply chain strategy and adjust your supply chain strategy to these things that are happening. So how does this help, and why does this matter so much, the ability to be able to adapt?
Yeah. So, in the paper, we talk about kind of two key capabilities, agility and resilience for supply chains. So we define agility as the ability to respond very quickly and rapidly and cost effectively to short-term changes in demand or supply conditions, right? So if, for example, we are responsible for providing warranty services for our products, and if we know that we can't predict demand for part failures, how do we manage inventory of spare parts to deliver services quickly within the terms dictated by our service level agreements? That would be an example of agility, right? Resilience, on the other hand, is the ability to adapt quickly to significant structural changes in our supply chain environment. So when events like COVID or the war in Europe happen, how can firms quickly bounce back from such significant disruptions is what resilience refers to. Mm-hmm. Now, companies that don't have these capabilities suffer in terms of higher costs and lower levels of customer satisfaction. And companies that do ultimately are rewarded by have higher levels of competitiveness and margins in their markets. It's not like these issues are new. I mean, both these capabilities have always been very important. Right. We've had major disruptions in the past. Before COVID, we had SARS, we had MERS, we had floods in Thailand, the Fukushima disaster. These all had very serious impact on, for example, semiconductor supply chains. Yeah. I think it's just that the scale and the simultaneous kind of global impact of these latest disruptions that you mentioned, they really shine the light on very intensely on this need. And the C-suite, I think, across industries is now quite aware of the importance of building agility and resilience in supply chains as a strategic necessity, as a strategic imperative. And I think most companies are now beginning to realize that there is a sense of urgency in this regard. We can't wait for the next disaster and then start thinking about agility or resilience. I think this needs to be a core element of a company's supply chain strategy. And this ultimately, you can have the greatest product in the world, but if we can respond to customer demand quickly, cost effectively, and when disruptions happen, recover from that very quickly, none of the rest of the stuff is going to matter. So I think this is why these capabilities matters, and this is why companies need to stay focused on this topic.
Really, yeah. I mean, it's the difference between success and failure. We saw a lot of companies fall by the wayside, really, when the challenges came up. The challenge of COVID, for instance, some succeeded, some rose to the top, and some fell back. And obviously, there has to have been some strategy involved in getting those companies ahead versus the ones that maybe were flying by the seat of their pants a little bit, and things might not have worked out as well.
Yeah, and I think you've hit the nail on the head. I mean, really, companies that were prepared, whether on purpose or whether it just happened that way by accident, I think they are the ones who came out ahead and continue to shine. You're absolutely right on that.
So backing up a little bit, machine learning, I think people have heard of it. We hear the conversation more about AI, definitely, that as the all-encompassing AI. But tell us a little bit more about, in this phase of things, where machine learning fits as a concept, and how it's used, how you suggest it be used in supply chain planning, also, and maybe how people are misusing it if they're not doing it the way that you're suggesting.
Mm-hmm. Yeah. Well, this is obviously a big topic. We devote several courses on this topic of machine learning, and
so we can just compact those down into a couple minutes, right?
Yeah, so I'm going to try to do that and hopefully do justice to the topic. AI, of course, is the umbrella term, and roughly speaking, it's the science and engineering of making intelligent machines that can mimic human behavior. So when we, collectively first started this AI journey in the late 20th century, it involved explicitly telling machines and computers what to do. Rules-based decision-making or expert systems. That's kind of how we got started. But subsequently, we realized that instead of telling a machine what to do, which is difficult, what if we could just provide it lots of examples to a computer and let the system figure out the relationship between the various inputs and outputs by itself? And that was the idea that led to what is now referred to as machine learning, which is a subset of artificial intelligence. This input data could be structured data, like data in spreadsheets, or it could be unstructured data, like images or video or audio or text, right? So when we talk about machine learnings, there are, broadly speaking, two main types of machine learning methods. There are methods that are referred to as supervised learning methods. These are methods that use data that include labels to train algorithms. So, if you think about image recognition systems, they use labeled images of X-rays to detect if an X-ray shows a healthy or a cancerous image, right? Unsupervised learning is the other form, where it does not use labeled data, but it looks for patterns in data. So you may have heard of terms like clustering. So if you have data on the location of households within a city, and if you want to divide them, say, into 10 clusters to determine the ideal location of coffee shops in the city to provide fastest access to all the members, that would be an example of machine learning using unsupervised learning. And then there are a couple of other methods as well, semi-supervised learning, reinforced learning, deep learning. These are all different types of machine learning methods. And so if we have access to these kind of methods and the appropriate training data on which these models can be trained, we could use them to find patterns in data and ultimately predict, say, demand for products, forecast demand. And so this forecast, in turn, could then be used as an input to a supply chain planning exercise that ultimately can help managers recommend the appropriate decisions about how much to produce, where and when and how to ship products, how much to stock at each stocking location, and so on. So most instances where machine learning is used in supply chain planning, primarily are used for the purposes of forecasting or prediction of demand. And there is a lot of excitement about this possibility of using machine learning to forecast demand and to do it in a way that's better than just using an ad hoc method or the other more traditional methods of forecasting.
Yeah, there's excitement around it, but there are some limitations if you're just going straight ahead with, here's the forecast, let's base our entire strategy around this machine learning generated forecast. So what are the limitations?
Yeah. So, per se, there's no problem with using machine learning for forecasting. In fact, if it's done right, obviously it can help improve the accuracy of forecasts, which is a good thing. But my co-authors and I, we think that any such forecast-driven planning process is fundamentally a flawed idea. I know that this is a provocative idea because most companies start with a forecast. So let me try to explain. By the way, this approach of using a forecast-driven process in the literature is often referred to as the PTO process, or the predict then optimize planning process. Right, so it's a two-step process. So what do we think is the problem with this? Well, I think several. First, I think in most companies there's almost never a single forecast that everyone can agree on for planning purposes, right? So, for instance, in one of the companies that we work with, the sales team developed a rolling monthly forecast of aggregate sales for the next 12 months. The inventory planning team, they developed their own forecast, but at a weekly level, because that's how they place orders with their suppliers. Its major retail customers managed a network of thousands of stores. They developed their own weekly forecasts. So these forecasts all varied significantly from each other and were made at different points in time. So they all used different data, different assumptions, and it was just never clear which was the right forecast to use. Forecasts can be biased depending on who the decision maker is and what their incentives are. Inventory teams tend to be very conservative because they want to minimize obsolescence and inventory costs. Retailers want assurance of supply, so they tend to overestimate demand. So that's another problem. But I think, most importantly, even if we had perfect forecasts, that's not going to be enough to make the best supply chain planning decisions, because these decisions also must take into account a whole variety of other factors. For example, there are a variety of constraints in any supply chain. There's production capacity constraints, there's logistics constraints, there's warehousing, storage constraints. There may be regional or customer-specific requirements. There might be local content rules, business agreements with customers. The profitability might differ in different regions. So even if a forecast is available, a fairly complex problem still remains to be solved, ultimately to determine the most profitable and cost-effective inventory-related supply chain decisions, right? So in other words, the forecast is really not the end goal. There's nothing sacred about a forecast. Ultimately, what we need are planning decisions. And for that reason, if you rely solely on the traditional machine learning methods, that doesn't help, because that doesn't help us get to the last step. It might help us with the first step, the predict step, but given all these other problems you're talking about, there still remains a long distance between the forecast and then the final decisions. And that was really the problem that we wanted to address.
Yeah, it becomes just another one of those forecasts to consider, basically another data point in the consideration process. So you mentioned decision, and decision is the final goal. So how do you get there, and why is it so important to get to that point of a decision making, and with machine learning helping?
Yeah. So this idea that the key outcomes needed, the key outcomes are what's needed, not the forecast. The decisions are what are important, was really the key insight that formed the basis of our approach, which is what we describe in this paper, where we are proposing replacing this two-step PTO, or predict then optimize approach, with a single step, essentially bypassing the forecasting step, altogether. So our approach is something that we refer to as the optimal machine learning method, or OML method. And the idea is that we, using this approach, directly determine a mathematical relationship between input data and the final supply chain decisions. So the input data might be data about supply chain network itself, sales and shipment transaction history. It could be past or upcoming promotions, capacity constraints, logistical constraints, etc. The final decisions that I'm talking about include, production quantities, replenishment orders, inventory stocking decisions at each location in your network, at each time period, and so on. And of course, these decisions need to be such that they optimize the most important KPIs, right? Profits, margins, service levels. But we want to do it by product, by customers, by region, or by geography, whatever is important. So, think of a mathematical function, which we call as a decision function, which can then be used to directly make recommendations about all planning decisions, which is what we are ultimately interested in. Of course, if a forecast is available, we can use that as an input to our model as well. Yeah. And the model will figure out what's the appropriate weight to assign to that input. And so what we do is we develop that decision function by training our model on the available history, much like the machine learning framework. And we update that function as newer data becomes available. Now, building such a decision function is not easy. It requires us to first build a comprehensive digital representation of the entire supply chain network, which we refer to as the digital twin. And the key is to do it at a level that is highly granular, down to the transaction level. And we want to do it in close collaboration with all the relevant stakeholders in the supply chain, so that everyone's objectives and goals can be properly accounted for. Now, in turn, that requires a data storage architecture that can provide the right information at the right level of granularity in the right format, and in a way that it reflects the supply chain structure, so that it can be used by our optimization engine. So in contrast to the typical machine learning approach of throwing all the data at a problem and seeing what's relevant, we start with using only data that are relevant, and then assign it weights that reflect their importance to our decisions, which is what really matters. So once we have all of these ingredients, we then solve literally millions of very large-scale mathematical problems very quickly to come up with a decision function. And this is where the ability to formulate the problem correctly, the right problem correctly, and solving it quickly using advanced computing capacity becomes very important. So the OML approach really can provide supply chain planning decisions very quickly, which can speed up the typical slow and sluggish S&OP processes and cycles that we typically see. And I think this is what will allow companies to infuse agility into their decision-making process. The latest data can be quickly and easily ingested into the model, and that can provide the best way to deal with change situations rapidly, so that we don't have to wait until the next S&OP cycle next month to argue and debate about the next steps. And I think the last point I would make is, because the data are stored in a manner that reflects the supply chain structure, it can be visualized in a very meaningful manner at the right level of granularity. And we found that greatly helps with user acceptance of this method. Because with many other conventional machine learning methods, it tends to be like a black box. And if people are smart, people who have been in business for a long time, they're smart, they understand the business. But if they can't understand the reasons behind any model's recommendations, they'll tend to not accept it. So I think being able to visualize the results in a meaningful manner and help the users understand why the results are what they are, I think is really the key to user acceptance.
Yeah, the user acceptance piece is the other key really to this whole process, because implementing such a system, you have to have the buy-in from the people who actually sign the papers and make the actual decisions.
Yeah, exactly.
So jumping back a little bit, we talk about inventory as one of the key pieces here in the forecasting, all of that. Supply chain is such a broad term, and there's so many pieces to supply chains, and so when our operation here, we're talking about the logistics piece, where the transportation and shipping, freight. So how does when you get to the more granular pieces, how does it incorporate those? How does it involve maybe choosing a transportation mode, or evaluating how those modes have been working?
Yeah. I'm glad you asked this question. I think it's an important question. As you noted correctly, excuse me, correctly, I think logistics is a very key, important component of supply chain management. And efficient logistics can really make or break the performance of any supply chain. I think we all remember what happened when the tanker got stuck in the Suez Canal, and more recently the challenges in the Red Sea. So I think logistics is really key, and your industry is playing a very, very important role. I think our approach, the OML approach, can help analyze the impact of logistics related decisions in, I think, two different ways. First, the digital twin that I talked about can be used to perform what if analysis on historical data. What would have happened if we had used air freight instead of ocean freight? Our shipping costs would have increased, but our inventory related costs could have been a lot lower. And the model can quantify network-wide impact on the KPIs that are relevant very, very accurately. But more importantly, the digital twin can also be used for future scenario planning. So, for example, what if the shipping time from Asia doubles because of a blockage of a major shipping route? What if a major distribution center is rendered inoperational due to an earthquake? What if the demand significantly drops in one region due to some sort of a political disruption, or increases because of a new product launch? Which specific regions or customers will be impacted, and by how much? How long will our customers be impacted for, and how long will it be before we can recover from those kind of disruptions? So I think in each of those cases, what might be the most effective risk mitigation strategy is something we can figure out using the results from that kind of analysis. So the key really is to be able to quantify the impact of these kind of disruptions, these kind of changes to one's logistics strategy at the appropriate level of granularity, whether it's by product, by region, by customer, or whatever is the right level of aggregation for a particular business. The OML methodology, I think, offers the ability to conduct this kind of analysis, and I think it's that sort of an analytically driven capability that can really help managers devise supply chain and logistics strategies to build agility and resilience in their supply chains. So I think the logistics industry can definitely find a lot of value in using this sort of an approach.
Yeah, the agility and resilience when it comes to companies who ship freight. I mean, they need to have backup plans. They need to evaluate how the times worked. I mean, there's also even the sustainability component to see how efficient something is, and can they maybe find more efficiencies going forward. So yeah, I definitely see a lot of applications there as well.
And I think you're making a very good point. I mean, I think it's not that companies don't know that's what's needed. I think the hard thing is figuring out how to evaluate those ideas or those strategies, right? So that methodology to actually figure out whether option A is better or option B is better. I think that's what has been missing, and that's the hole that this approach that we talk about can fill.
And so you did have a couple of example companies. What did you find when they implemented OML?
Yeah. Well, so we in the paper we talk about our experience with companies in two very different contexts.
Right.
In one case, this was a company in the semiconductor equipment industry, which managed, they provide warranty and repair services to their customers. So they had an assortment of, I think 30 or 40,000 stock keeping units that they had to manage effectively. And we found that if they implemented when they implemented the OML methodology, they could offer a better service with significantly less inventory, or if they were happy with the amount of capital investment in their inventory, they could actually increase the level of service, quite significantly, which implies greater revenue for them. Mm-hmm. The second example was interesting because it was different than the first one. There, the company had a smaller assortment in terms of the number of SKUs. They, I think, only 6 different SKUs. But the structure of their supply chain network was very different from the first example. They had a contract manufacturer in Asia. They had the major distribution centers here in the United States. They sold through retail channels, through large retailers that operated thousands of retail stores. So the supply chain structure was very, very complex. And we were able to, using our methodology, identify some key shortcomings in how they were currently making decisions in their supply chain. We were able to identify locations where they were carrying way more inventory than they needed, and other locations where they were not stocking enough inventory. This company, obviously, they were an OEM, so they were not directly making decisions about retail store level inventory deployment. That was the retailer's responsibility. But when they have a tool like OML, they can actually have a meaningful conversation with their retail partners and say, look, this is how you're deploying inventory, but here's a better way. Because if you do that, it's a win-win. The retailer wins because they have greater sales, and obviously that translates into better revenues for the OEM as well. So very different environments in the two examples, but in the end, the outcomes were better asset utilization and greater revenue for all the parties involved, and higher value for consumers.
Yeah, and doing this exercise with a couple of disparate companies really shows that it does have application kind of across the board.
Exactly.
So when we talk about OML and any kind of AI, machine learning, there's always a little bit of a pushback with the idea from some people that this is taking the human element out of it. We're going to be replaced by robots, all that sort of thing. But I mean, it really seems in the paper and in what we've discussed so far that you're not discounting the human element as part of this decision making.
Mm-hmm. Yeah, I think that's a question that's getting a lot of attention these days in the media, and I think it's a good question and the right question for us to ask. But our view is that the human element and human expertise, I think they're crucial to the success of the OML methodology. And I think there are at least 2 ways in which the human expertise will continue to be very important. I think first, in the initial development of the optimization engine and the digital twin, it is absolutely critical for the model to capture all the objectives, all the goals, constraints, and business rules relevant to every stakeholder in the supply chain. This is important to understand how the decisions will impact KPIs for everyone. Ultimately, the success of any decision will require carefully addressing all of these trade-offs, and the methodology that we have here can greatly facilitate the negotiation that will necessarily accompany any such conversations, because it's going to affect different parties very differently. Moreover, since any business environment is going to undoubtedly evolve over time, that means that its representation needs to constantly change as well. So the human input in how the model is set up will remain critical, both at the initial point when we first put the model together, but also as the model continues to be used. Second, I think by definition, all analytical and digital representations of business systems require key assumptions to be made. And that means that they cannot actually accurately capture all aspects of reality. That's just by definition. Even the best analytical model can't capture reality perfectly. So therefore, I think any system's recommendations must be verified by human experts. So in this sense, we really think of the OML platform as an effective decision support system, which can greatly improve the speed with which firms can operate. So it can relieve humans of the tedium that certain kinds of analysis requires. And so it can free them to focus on the more important strategic and creative decisions that are likely to be much more exciting and fulfilling for those individuals involved in the planning process.
Mm-hmm. And sort of pivoting off of that, we're in graduation season. You've been teaching a while in this industry, and we've talked about machine learning and AI and their evolution. Obviously, technology is playing a big role in how the profession has evolved over time as well. So, what's your outlook right now for those who are just walking for graduation, or maybe considering this as a profession coming from high school level or somewhere mid-career?
Yeah. Another great question. Yeah, it's I think it's a very relevant question, because as academics we have to constantly ask ourselves and struggle with this sort of a question. But it's a good thing that this question keeps coming up. This is not the first time we've had a significant change. There have been lots of very significant technological changes that have had a huge impact on what we teach and how we teach, because ultimately that's what students are going to make use of when they join the workforce. I'm going to date myself a little bit here. I remember when I first joined academia in the early 90s, the first major change that took place was the rapid deployment of desktop and personal computers, right? Yeah. So, I go back a long time. Then came the launch of the Office suite and the ever-expanding capabilities of spreadsheets. Mm-hmm. And then came the internet and the kind of information, it makes information available just at our fingertips. And then, of course, as you said, the giddying excitement around AI, and particularly Gen AI. And I think all of these kind of developments have caused us to rethink what we teach, how we teach, but and the implications for students. But I think through all these changes, there's always been one common thread. I'll take an example that'll resonate quite well with your audience from the logistics industry, the transportation industry. So think about the well-known transportation problem, right? A company has several facilities that stock inventory of some products and several different markets that have different demands. The cost of shipping could vary on different routes, as does the amount of shipping capacity on each route. So the goal for this transportation company is to determine the optimal amounts to ship from each source to each market, so that the demand can be met in the most cost-effective manner. This is a basic problem that is very important to people in your industry.
Oh yeah.
So it turns out that this problem is a very nice mathematical structure, which we can formulate as something called as a linear program, right? And then we can solve that. So before we had access to this ubiquitous computing, we would teach our students the linear programming method so that they can go out in the real world and use that method. But the calculations had to be done very painstakingly, very manually, using something called as the simplex tableau method. So at best, we could solve very small toy problems. Now, as computing advanced, the computational capabilities increased of even things like Excel. We were able to solve bigger problems, and students could learn to incorporate more important constraints, more relevant constraints. With the development of the internet, access and distributed cloud computing capabilities, we could solve even larger problems, enterprise scale problems, almost in real time, not just in batch mode. And because we can do that, we can now imagine business models that can respond to supply and demand conditions in real time. Think of Amazon Prime as an example.
Yeah.
So what this means is that our focus in the classroom has shifted from the question of how to solve problems to what problems to solve. And we still talk about the how, but now we have the technology to do that work very efficiently for us. Right, so we can now focus on being smarter about asking the right questions, about formulating the problems correctly, the right problems correctly. And I think this is going to become even more important as Gen AI develops, because it seems to be able to do problem formulation and solution, but we all know that we're going to have no idea whether it's doing it the right way. It hallucinates. It hallucinates all the time by definition. So the person who gets the most value out of technologies like AI or any other such technology really will be the person who knows what to look for and what to expect. And I think that's what the students coming out to the workforce need to remember. So I think, on our end, we're going to keep pushing our students on being more rigorous and smart about thinking about the problem and less about the answers. I think that's kind of a key imperative for people in the industry and for students graduating. I think the other big change that all these kind of developments is allowing us to address is who is able to address these problems. So currently I have students in my supply chain class, my graduate class. They are working on, for their class project, supply chain problems being faced by a very innovative company in Kenya, which has launched a new class of electric motorcycles and three-wheelers. Well, Kenya is far away. So despite the distance, the difference in distance, the distance and the difference in time, our students are able to collaborate with them and solve problems that are stemming from having a global supply chain. This is not something that we could have imagined doing with our students a few short years ago, right? But now we can do that. Yeah. So I'm just really excited about all these developments in technology that allow us to work on problems that we don't know about yet, using methods that we don't know about yet, and with people who we don't know yet. So I think we're going to certainly keep teaching our students about the latest supply chain related business problems, how to solve these problems at scale, and technologies that can help them implement these solutions at scale. I think students need to be aware of those kind of capabilities. But I think most importantly, people who are graduating now, people in the industry today, need to stay excited about learning about problem solving. And they need to stay excited about making an impact. Whether it is to their companies, whether it's to their community. I think that's, as long as they have that, the curiosity to learn and the interest in making an impact, I think they are the ones who are going to succeed in today's world. And as academics, I think we are in a very privileged position because we get to play a very small role in helping students and the workforce be prepared for this very, very rapidly evolving world.
And I see the excitement coming from you related to the industry and to the profession still. So I think that definitely passes down to the students as well. So we'll have the link to the article we discussed. Is there anywhere else you'd point people to find more from you?
Well, so we, my CV, of course, is on my university's website, www.sc.edu, and you can search for Naren Agrawal on there. And for the best source for looking at papers that academics like me write is Google Scholar. Go to Google Scholar, enter Naren Agrawal, and you'll find this as well as links to this, as well as all the other papers that I've been fortunate enough to work on.
Great. Dr. Agrawal, thanks very much for your time. Appreciate it.
Thank you, Kevin. I really enjoyed this, and thank you for hosting this amazing podcast, and good luck. And I do want to take a moment to thank everyone in the logistics industry. You guys really are the backbone of society, and I hope you keep doing the amazing work that you do.
Thanks very much for joining us for InTek Freight and Logistics, the podcast, and another thank you to Dr. Naren Agrawal for taking the time to speak with us on this episode. Check out the links in the description for more about everything we discussed, including the article and much, much more. Subscribe or follow now to ensure you get our latest episodes as soon as they're available, whatever platform you are watching or listening on. Also, please rate and review. And drop us a comment. We certainly appreciate those if it's a question or if it's some added feedback. Anything you'd like, more than appreciated. And if you have a more detailed, longer question, feel free to email us at podcast@inteklogistics.com. Our website is intekfreight-logistics.com for more about what we do. So again, thanks very much for your time in this episode. We'll be back with another one soon. So we'll talk to you next time.